get started on today's lesson. If you still need to, you can take a screenshot of all the formulae for the volumes of certain shapes. Please take a screenshot. It will be very helpful, especially for today's lesson, because we're going to do some things that are a little bit more techy. All right, okay. So let's do a little bit of a different kind of volume question. Okay, I want you guys to read through this question and then please tell me with a thumbs up or a thumbs down if you're going to be able to do this question all your own. Don't just start thumbs down. Read it, think about what you need to do, and then say, okay, yes, ma'am. Because it's actually quite easy if we think about it. We've been given the volume. I will remind you guys again, because I'm nice like that. I'm going to remind you guys. The volume of a sphere is 4/3 radius cubed. Oh, and we don't need to calculate for the surface area. So don't worry about the surface area part. I just want you guys to calculate for the radius. Okay. Oh, okay. I won't erase it. I won't erase it. Okay. Are we able to calculate for the radius? Yes. I'm going to give you guys some time. Go for it. Narisha's done. Lovely. I did. Yes, I did. I'm so sorry. Thank you, Theo. I forgot pi. I'm so sorry. I'm so sorry. You're so right. 4/3 pi radius cubed. Sorry, guys. If I messed you up, I'm so sorry. I forgot the pi. Sorry, Justin. I'm so sorry. It's just a quick calculation. Quick. Sorry, Narisha. Sorry, Sanele. Such many shameful experiences today. It's just not, things are not going my way today. Oh my goodness. Sorry, guys. I'll give you guys one more minute because this question isn't actually that difficult. It's quite okay. Okay. All right, let's have a look. Okay, so the thing is, in this particular question, they've given us the volume. They've told us that the volume is this. So all I'm going to do is I'm going to go into my formula and I'm going to replace the volume part with that. Sorry, Gift. Sorry. Okay, so I'm going to go 3705,97 is equal to 4/3 pi times the radius cubed. Now, I know that I want the radius, so I'm going to isolate radius cubed. So I'm going to therefore get radius cubed is equal to 3705,97 divided by 4/3 pi. That's the answer I should get. Okay. Oh, there's another one coming. But now I know that I want to get rid of the cubed. I don't want the cubed. And the way to get rid of a cubed is to take the cube root. Take the cube root of both sides so that the cube and the cube root can cancel each other out. Therefore, the radius should equal the cube root of that answer, which is 9,6 millimeters. Lovely. Easy. Okay, actually it's 60 because it's 5,999,999. So 9,60. Easy. Millimeters, not difficult at all. Princess, did we struggle? Did you struggle, my dear? If you did, I'm here to help. I'm absolutely here to help. Oh, no. It's okay, Gift. It's okay. All right. Okay, let's look at the next one. The next one is a little bit challenging. It's going to need you guys to read, break it apart into its pieces, and then give an answer. Okay. And unfortunately, I refuse to help. I'm not going to help. I'm going to just interpret the answer for you guys at the end. Also, I need to go fetch tissue so I can blow my nose. So I'm going to leave you guys alone for a couple of minutes. Okay, I'm just going to quickly get to grab some tissue. But here is the question. Read it properly. Read it 100% properly. Read it. Read it carefully. Okay, break it up into its parts and answer the question. No, Theo, of course not. I would never do such a thing. I'm only helping, not hindering. All right. Gift, we always have to try. We must always try. If we can't do, we at least try. Okay, I'm going to go get tissue to blow my nose out. I see you, Narisha, the instigator. The instigator. I caught you today, red-handed. Let me screenshot. Let me just screenshot. Screenshot. I'm sending to the feds. Me, I'm a snitch. I'm not getting caught in the middle of all of these things. Hello, Abu. Oh, we bomb make them cake. Oh, is that where we're going? Oh, we bomb make them cake. Okay. Okay, I see you. Guys, I don't eat sweets. So Abu, we're already off to a terrible start. Sorry, guys. Okay, all right, let's focus on the question, guys. Okay, let's have a look over here. All right, so we have been given a shape, right? This shape is a composite shape. Let's talk about what this shape is made up of. What is this shape made up of? Tell me, what other shapes is this shape made up of? It's made of three. Good. One of them is a cone. Right, a cone and a half sphere and not a rectangle. It's a 3D shape. That's it, Theo. And a cylinder. That's it. So we know that we need to calculate for whatever it is that we're calculating, we're going to need to break it up into 3 parts. Do you see why ma'am said you're going to have to strategize? Strategize. Gift. Not nice. Okay. All right. So let's read the information that we've been given here. This says the cylinder has a radius of 8 centimeters. So my cylinder, the inside part here, has a radius of 8 centimeters. That's a dead giveaway. Who can tell me why that's a dead giveaway? If my radius is 8 centimeters. What are we thinking? Why is that a dead giveaway? We don't have half the cylinder, we have the full cylinder, but we know that the radius of the cylinder is 8 centimeters, right? But what is the cylinder connected to? What is it connected to? It's connected to the cone, and it's also connected to the half sphere. Yeah? So what is the radius of my half sphere? What's the radius of my half sphere going to be? 8 centimeters, exactly. What is the radius of my cylinder of my cone going to be? Not my cylinder. What is the radius of my cone going to be? 8 centimeters. So technically, because they're all connected to each other, they're all going to have the same radius. Yes? 1 plus 7. Thanks, Justin. Okay. All right. Now it says the length of the cylinder is twice as long as the radius. So what is the length of my cylinder? How long is my cylinder from here to there? If it's twice as long as my radius, it should be, that's it, princess, it's 16 centimeters. Okay, let's keep reading. The next part says, the cone has a height that is 3 halves of the cylinder's radius. Okay, it's 3 halves of the cylinder's radius. So we know that the height of the cone is going to equal 3 over 2 of. What does of in mathematics mean? Of means multiply. 3 halves of 8, which is also how much? How much are we going to get there? We get 12 centimeters. Okay, 12 centimeters. Okay, we're not going to worry about the surface area. Remember, we're actually talking about the volume today. All right, so that's 12 centimeters, which means the height of my cone is 12 centimeters. Now it says determine the volume. Guys, come on now. Okay, the volume of a sphere is 4 over 3 pi radius cubed. Remember, it's half a sphere. The volume of a cylinder is equal to pi radius squared times the height. And the volume of a cone is 1 over 3 pi radius squared times the height. So really, we just needed to read. That's all. We just needed to read through the question. Okay, shall we calculate? Can we calculate, guys? Yeah, we're going to put all these volumes together. We're going to put them together. I've put all the dimensions on the actual drawing, so we don't have to worry about it. So I'm going to go the volume of the cone plus the volume of the cylinder plus half the volume of my sphere. Okay, therefore volume is equal to Volume of my cone will be 1/3 pi times the radius. They all have the same radius, so 8 squared multiplied by 12 plus the volume of the cylinder is just going to be pi times 8 squared multiplied by 16 plus half of 4/3 pi times the radius, which again is 8 cubed. And all we need to do is punch that into your calculator. Sanela, what did you get? What did you get? I'm just going to do it in stages. Otherwise, it's going to confuse me. 256 pi plus. We forgot to put the half. It's a half sphere, right? Plus 1024 pi. 1024 pi plus 4/6. 4/6 times pi times 8 cubed times 8. Where is the cubed button? Cubed. Okay, and that gives us 1024/3 pi. And we can just take all of those and add them together. Equals. Okay, 256 plus 1024 plus 1024/3 equals 4864/3 pi. Multiply all of that by pi is equal to 5093,57. Okay. All right. Was that as difficult as it looked? No, I don't think so. I think it was pretty okay. Okay, like I said, we just needed to unpack it and understand exactly what information they've given us, because most things are drawn in symmetry. Okay, all right. I need to teach something new today, especially because of your quiz this evening. All right, we're going to learn scale factor. And then when we get to the end of the lesson, I think this is going to go quite fast. When we get to the end of the lesson, Sanela is going to give us some of those really tough questions that she got at school today. And we can kind of look at the difference between my questions and the questions that she's getting at school. All right, let's talk about scale factor. So we're going to pretend that this is a small rectangle and this is a big rectangle. Okay, so scale factor, no. Fear factor, yes. All right. Okay, so if I were to ask you guys, by how much have they increased the dimensions of my small rectangle to make my big rectangle? That's a short stuff. It would be by 3, right? To get from 6 centimeters to 18 centimeters, that's multiplied by 3. To get from 2 to 6, that's multiplied by 3. Right, we're just multiplying by 3. So technically, we should be able to say that the scale factor is 3, right? We should say that the scale factor is 3. However, if we were to calculate the area of this triangle, I know that the area of a rectangle is just length times breadth. I'm going to get 6 times 2, which is 12 centimeters squared. And if I were to calculate for the area of this rectangle, 18 times 6 is the same as 9 times 12, which is 108 centimeters squared. Now, if I were to take these two, let's just do this. If I took 18 and I divided it by 6, I would go 18 divided by 6, and that would give us our scale factor of 3. And if I took 6 and I divided it by 2, 6 divided by 2 would also give me 3. Now, let's do the same with the areas. If I take the area of the bigger rectangle, 108, and I divided it by 12, what do I get? What answer do I get? Anybody got an answer? 108 divided by 12, 9. Why does this one not give us the same scale factor? It doesn't give us the same scale factor because what we've actually done to calculate for the area is we've multiplied this side by 3 and we've multiplied this side by 3. So when we look at the area, that's it. The area of my, or the scale factor for my area is actually 3 squared. Thumbs up. Making sense? Yeah, nothing too tricky here. It's looking about the same. Amazing. Amazing. All right, let's look at volume. And now, let's look at an example and then we'll go to volume. All right, so they say here to us that a box, and I'm just going to draw like a 2D box. A box has an area of 3,5 meters squared, right? Now it says, if the length of each side is increased by a scale factor of 4, what will the new surface area be? What will the new surface area be? Okay, and I know it's supposed to be a 3D because it's surface area, but you get the idea. So now I know that if I go in and all the sides, each side is increased by a scale factor of 4, that means times 4 times 4. Agreed? Times 4 times 4. So when I want the new surface area, I'm going to have to take 3,5 and multiply it by 4, not just 4 squared. Somebody give me an answer. What do we get? 56 meters squared. All right. Are we all okay with this idea? Anybody a bit stuck and need me to re-explain something? We all good? Okay. Lovely. Let's look at that. Let's look at these two rectangular prisms. Okay. Now I know 6 divided by 3. 6 divided by 3 is equal to 2. I also know that 8 divided by 4 is also equal to 2. And 4 divided by 2 is also equal to 2. 4 divided by 2 is equal to 2. So it's safe for us to say that the scale factor is 2. Right. But these are 3D shapes. Let's calculate for the volume. Okay. The volume is equal to, or the volume of the smaller one, we're going to say this is the smaller one and this is the big one. The volume of the, no, let's calculate for the volume of the bigger one on the top because we're going to divide. The volume of the big shape is going to be 6 times 4 times 8, which is equal to 24 times 8 is equal to 192. 192. And the volume of the smaller rectangular prism is going to be 3 times 2 times 4. And that's going to give us 6 times 4 is 24. All right. Okay, now if I take these two volumes and I divide them, okay, the volume of the 192 divided by 24, how much do I get? What do I get here? 192 divided by 24 would give us 8. But that's not our scale factor. Our scale factor is 2. How did we get there? How did we get from 2 to 8? That's it, princess. It's because even though my scale factor is 2, for the volume, it needs to be 2 cubed. All right. Okay, let's look at an example. All right, here's an example. It says, a bottle has a volume of 200 centimeters cubed and a height of 12 centimeters. Another bottle is mathematically similar and has a height of 18 centimeters. What will the bottle of this, or what will the volume of this new bottle be? We want the volume. Now, the first thing we always need to work out, look at this question here. first thing we always need is a scale factor. Right, same over here. The first thing we always do is we find a scale factor. So let's go ahead and find a scale factor here. Now, I've got two heights from two different bottles, right? So I'm going to take the volume or the height of the bigger bottle, and I'm going to divide it by the volume of the smaller bottle. 18 divided by 12? 3/2, which is the same as 1.5. We can do 1.5. Okay, 1.5. So my scale factor is 1.5. It's 1.5. But now they want the volume of the new one. We know that the volume of the old one was 200 centimeters cubed. So I know that the volume of the new bottle needs to be 200 meters, not just times 1.5, but it needs to be 1.5 cubed. That's the answer we're looking for. All right, so we're looking for 200 times 1.5 cubed. Anybody can drop an answer in the chat for me. That's it, Theo. 675 centimeters cubed. All right. Okay, ladies and gents, thumbs up. Are we all happy with how this works? Yes, nice and easy. We got this. I'm going to give you guys a question to try. Okay, so I'm just going to remind you guys that whenever you see the word milliliters, it's because you can easily convert that to centimeters cubed, because technically in mathematics and in measurement, 1 centimeter cubed is equal to 1 milliliter. So wherever you see milliliter, we're just going to replace that with centimeters cubed, which means we are calculating for the volume. All right, pop your answers in the chat when you're ready. Anybody got an answer for me? Anybody? Somebody? Saying 101.25 centimeters cubed. All right, let's see. I like it, Theo. Good work. All right, so first thing we're always going to have to find is our scale factor. Let's find our scale factor. Now, the information I've been given here tells me that the smaller bottle has a height of 6 centimeters, and the larger bottle has a height of 9 centimeters. So I know that I can find my scale by taking 9 divided by 6, and that will just give me 1.5. Again, 1.5. All right, so my scale factor is not 1.5, but because I want the volume of the larger perfume bottle, I'm going to take the volume of the smaller bottle, which is 30 centimeters cubed, and I'm going to multiply that by 1.5 cubed because it is a volume. right? And that is equal to, indeed, 30 times 1,5 cubed is indeed 101,25 centimeters cubed. Well done, Theo. All right. Are we all happy, sirs? Ma'ams? Are we good? Amazing. Here's another one. Let's go. Hi, Bo, Narisha. I did no such thing. How Batum? What easy questions? What easy questions? They've given you the scale factor. We can see it. This time they've given you the scale factor. This is such an easy question. Something like this, yes, Abu. Or it's usually in a drawing. So look for it in a drawing. Okay, and when we do our revision catch up next in the coming weeks, you'll see it there as well, because we'll have it. No, Narisha. That's not what that means. What that means is that the smaller shape is 1 and the bigger shape is 3. So technically the scale factor is 3. Does that make sense? Yes, the smaller shape is 1 and the bigger shape has a factor of 3 more. Okay, because scale factors are basically just ratios. Okay, let me explain that again. Okay, remember whenever we are doing these particular questions, right? We are comparing one shape to another shape. Are you okay with that idea? That it's two shapes being compared to each other. Yes? Okay, cool. So now if I have a rectangle and this side is 4, that means my scale of 1 is 4. The bigger rectangle has a scale of 3. How much will this side be equal to? 12, correct. It will equal 12. So this side will equal 12. Right. So now we know that the scale factor for each of the sides is 12. Is 1 for the smaller one and 3 to the bigger one, which means the scale factor in and of itself is 3. So now they've given you the surface area of the smaller shape. The smaller sphere has a surface area of 16 meters squared. And now they want the surface area of the larger sphere. So we need to take the scale of the larger side to get that one. Does that make sense, Narisha? Okay, amazing. Right. It's actually a sphere, but that's beside the point. Okay, anybody got an answer? This one should be quite easy. Correct, Abu, that's it. Okay, so, all right, we know that our scale is 1:3, so we'll just take the surface area is equal to 16 multiplied by not just 3, because it's surface area, 3 squared. And the answer is indeed 144 meters squared for the larger sphere. All right, are we all good, guys? Is this okay? Everyone okay? I'd hope so. All right, cool stuff. Okay, let's do something a little different. Let's work our way backwards. Okay, we're just going to work backwards this time. And I was just waiting for the comments, and then I'll give you guys a second to soak it in. It's not that bad. I'm going to do the first one with you. It's okay. It's okay. All right. So I want us to note, guys, that in this particular question over here, when we are given the smaller shape, we take our scale factor and we square it, or we take the scale factor and we cube it, depending on what it is that we need to do. Now, over here, they've given us both of the surface areas for both of our shapes. So if I want to calculate for the scale factor, I'm going to take the surface area of the bigger shape, 240, divided by the surface area of the smaller shape, 15. Someone give me an answer. 240 divided by 15? 16. Good. The answer is 16. But if we were working forward, the 16 would come from us having squared a number. Do you guys understand? The scale factor wouldn't be 16. It would be something squared. So what is that squared number? That's it. So we can take the square root of this because the actual scale factor is 4 squared. Is ma'am making sense? We've taken the scale factor and we've squared it. And so when we get 16, the answer that we actually want is the square root of that answer. Therefore, the scale factor of R to Q is 4. Okay. Got it? Are we okay? Okay, let's talk about this one over here. Over here, I've got the volume of the bigger shape and the volume of the smaller shape. So I know I'm going to take 4, that's not a comma, that's 4116 divided by 96. What answer are we going to get there? It's an ugly answer, I'll tell you that. That's it, princess. 42,875. Right. But remember, this is the cube. It's the cube. So we already know that we've taken our scale factor and we've cubed it. So what we need to do to find the actual scale factor is we need to cube root this answer. What answer do we get? 3,5. That's it. 3,5. So the scale factor is 3,5. All right. Are we okay with this? Yes. Thumbs up, everyone. It's quite easy if we know what we're doing. I will stop lying. Okay. Here's 2 examples for you guys to try on your own. Okay. Be very careful in terms of what you are doing with what. Make sure that you are either squaring or cubing accordingly. I know you are. I know you are. Oh, sorry. Remove the comma. This is the comma, 56,25. Okay. No, it's 3,125. Okay. The Americans use commas to separate thousands and hundreds. We don't do that in South Africa. And I got this from from a paper there. Okay. It's a long story. I can tell you, Narisha. I can, after the lesson. I can tell you why they do things so differently. But yeah, bottom line is, no. But you didn't hear that from me. No, Joe. No, gift, that's not why. No. No, Abu, that's not the reason. Okay, guys, do we have answers? Abu and Gift are starting about McDonald's. I'm gonna assume it's because we have answers for ma'am. Do we have answers for ma'am? So Justin, my grade 10s and 11s will start exams on the 4th of November. Okay, they'll start on the 4th of November. Okay. All right, peeps, let's have a look at these questions. Okay, so in order for us to find the scale factor, I'm going to take 3,125 divided by 675. And what I get is I get 125 over 27. And I can take the square root of this exactly the way that I look at it, right? I'm going to take not the square root, the cube root. I'm going to take the cube root of this answer. And the answer I'm going to get over here, 125 cubed is going to be, the cube of 125 is 5 over the cube of 27 is 3. So you can either leave it as 5 over 3, or you can click SD, which would then give us 1,67. Okay, 1,67. So we can see the answer quite nicely if we do it that way. All right, on this side, I'm going to get 729 divided by 56,25. So 729 divided by 56,25 will give me 324 over 25. And if I take the square root, because we are squaring on this side, we're using the square. If I take the square root of my answer, I will get 18 over 5, or if you click SD, you should get 3,6. I don't know where the 6,1 came from. I think it's because you already clicked SD before. There is no unit, V. The reason why there's no unit is because look at the way Abu is writing his answers. He's writing his answers as ratio. And scales are actually ratios. So we can actually write this ratio as 1:1,67. And ratios do not need units. Okay, do you understand what I mean? Are we okay there?